Welcome. Let's understand the graph of a logarithm function. Let's consider the function of log evaluated at x, where the base is 10. If we were to graph this function, we would obtain the following. Now let's analyze some key properties of this graph. When we take a look at the behavior of this graph, notice that it's only using values of x's that are greater than 0. On the left-hand side of the y-axis, there is no section of the graph. So we can claim that domain, it is from 0 to positive infinity. The right behavior, it has to be an open parenthesis. We cannot include infinity. And the left behavior, it's also an open parenthesis. And this brings me to my first point. When we look at the evaluation of the function of the logarithm, we can never evaluate it by the value of 0. So why is that the case? Well, let's evaluate it and let's see what's the problem. Now let's represent it as an exponential. Let's get our base, which is 10. And now let's raise it to the variable of y. And now that's going to be equal to what we have inside the function, which in this case is 0. And now we have a problem because there is no value of an exponent that we can place on the number of 10 that will give us 0 as an output. Can 10 be raised to any number and it will be equivalent to 0? Well, there's none. That's a problem. Therefore, 0 cannot be evaluated inside any logarithm function. And this idea also creates an interesting line. At the same location where x is equivalent to 0, we also have a vertical asymptote. Now, when it comes to the range of this function, notice that the left-hand side behavior, it is decreasing without a bound. The right-hand side behavior, it is increasing without a bound as well. So we can say that the range, it is from negative infinity to positive infinity. And then in addition, we will have an intersection on the x-axis at 1, 0. But why is that the case? Well, the x-axis occurs anytime the y is equivalent to 0. So let's set this equation equal to 0. And now we represent this as an exponential. Let's get the value of 10. Now let's raise it to the value of 0. And now let's set that equivalent to what we have inside the parenthesis, which in this case is x. Well, any value raised to the 0, it's always 1. So now we have our location. We have a coordinate point at 1, 0. So now that we have analyzed the function of a logarithm evaluated at x, would it be possible for us to move this function to any direction, either up, down, left, or right? Well, let's explore that idea. So here, in the right-hand side, we have our function of log, just as we did before. Notice that we have the same behavior, and we also have an x-intercept at 1, 0. Now, what will happen to this function if we add some number, let's call it c, outside of the function of log? If we start adding positive numbers outside the function of log, notice that my function, it's increasing. It is moving upwards. And now we go back to 0. And now we start adding values that are negative, which is the same as subtracting outside the log function. We are moving our function downwards. So there is a way for us to move our function either up or down. So let's summarize this. So when we consider any function of a logarithm, if we add a value outside of the function, this log function, it's going to move upwards. by a value of c. So we still have the same shape, it is just moved upwards. So when we have the same function of log of x, but now we subtract it by some value of c outside of the function, we are going to move our logarithm c units down. We still have the same shape, it is just moved downwards. Now what would happen if this addition or subtraction would have happened inside the function and not outside? Let's explore that idea. On the right hand side, we have the function of a logarithm evaluated at x. Now what will happen to this function if we add some value, let's call it c, inside the function? Now notice what will happen when we increase the value of c. When we increase the value that we're adding inside the parentheses, our function, it's moving to the left. And now if we go back to 0, what would happen now if we start subtracting inside the parentheses? Notice that our function, it is moving to the right. So now let's summarize this idea. When we added some value, let's call it c, inside the function, what it did, it moved our function c units to the left. And when we subtracted some number inside our function, it moved our function c units to the right. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.